Okay. All right. Hi, everyone. I'm Tim, as Ben said. I assume you can see my screen. I've lost my green outline. Cool. Okay, yeah, so I do Kubernetes at Analytium. I've only been here a couple of months now, but I did Kubernetes for a couple of years prior to that. So I've got quite a lot of experience with Kubernetes. Learned a lot about Viya and the other SAS stuff. So that's a bit of a learning journey for me. So anyway, this is things that I've learned and discovered and wished I'd known possibly before I deployed Viya. So the first one, and this is probably more for if you're an existing Kubernetes person, the node images that you're going to use, all of the container images are much, much larger than you would ordinarily expect. And there's also lots more of them. So if we look at this, if we list the images on one of the nodes, there's about 126 or so. And these are just the SAS ones. And if we actually have a look at what this takes up, so ordinarily when you scale in a cluster like this, your OS disk is probably going to be quite small. But as you can see, just from these SAS images here, you've got, 200, 300 meg then into the gigs. So this doesn't really fit in your cluster in the way probably your existing workloads do. So you definitely need to bear that in mind. Otherwise, you're going to start hitting disk space pressure, or you can have kubelets running around doing a lot of garbage collection. Next one, you've got two authentication options. There's the original Kubernetes local accounts with Kubernetes RBAC, which you probably understand quite well if you've done Kubernetes before. But then you've also got the Azure AD integration. There's some issues with this. If you go with the option we've got here, which is local accounts with Kubernetes RBAC, these are X509 certificates, as you'd expect, but all the certificates are for cluster admins. You can't grant a lesser privileged user, which is obviously a bit of an issue, and it's a bit of an issue. So you can do Azure AD with Kubernetes RBAC, and so you use your Azure AD principals there and you assign them roles as you would do normally. Or you can do Azure AD with Azure RBAC. Now this is really cool. I'd not seen this before starting at Analytium, but this probably integrates with the rest of the workflow quite well. You can switch between these, but there's a complex matrix of which way you can go and which way you can't go. And I probably wouldn't want to do it. I've tried it and it works, but it's going to start leaving cruft around in your role bindings and that sort of thing. So you probably want to consider that before you do a deploy, or at least do some test. This one's specific to Viya. NFS. Most cost-effective installations are going to want to use NFS to provide storage. But it's NFS 3, which means you've got a whole mess of ports open. It's not too bad if you've got your standalone Viya in an Azure cluster, probably in an Azure subscription that's not doing anything else. But if you're using VNets for other things, you're going to get into a situation where, excuse me, where your NFS is exposed to everything else on the VNet. I've been doing some work to try and move to NFS 4 because it's got a much more simple configuration. You haven't got all the port map problems. But that doesn't work quite yet. There's some weird stuff. And then the other one, when you deploy using the SAS providers for this, you can get the normal observability stack of Prometheus, Grafana, or OpenSearch and Kibana. But it doesn't actually deploy you any workbooks, Azure Monitor workbooks. So you need to do it yourself, but it's quite straightforward. But you'll get some really good visibility that you wouldn't otherwise get without quite a lot of Prometheus and Grafana configuration. So you can monitor the core stats, see what's going on, and then see what's going on with the NFS, which is probably your key performance factor if you are using the NFS provider. And then this one's really cool. They don't make this very obvious, but there's a really cool visualization called Hive clustering So say you're doing an auto scale, and you've got busy workloads. You start spinning up your node pools, and so you end up with sort of 3 or 4 instances for each of the different node pool types. This would give you a really good view, which you're not probably going to be able to see so well when you're doing it on a normal graph like this, because you start stacking another 5 or 10 of these, and it looks like colourful spaghetti. So it's definitely worth having a look around in the Azure Monitor options. They've got some really quite useful stuff. Right, I think I probably raced through that. I don't know, it feels like I did. So anyway, right, so some demos now. This is the gotcha section. And these are things that I discovered and could have caused quite a big problem. Right, so storage in Kubernetes it takes a while to get your head around it in the first place, because you don't really have just a disk attached to a service or a server anymore. Everything's objects and anything can run anywhere, and so you need to make sure that your data is visible to your pod wherever it gets scheduled. So we've got PVs and PVCs now. So PV, physical volume, that actually at some point somewhere does correspond to a chunk of disk and data on the disk. And then you've got a PVC, a physical volume claim, which is kind of your handle to access the data. So PVs have, excuse me. So PVs have got characteristics, the size, access modes, whether you can read it from one mount at a time, or like this read write X. You could have multiple pods connected to the PV. But the key one for this is the reclaim policy. So this is a fresh install of Viya 2022.9, which I did last night. And as you can see, the reclaim policy on all of these is delete. So what that means is when the claim is no longer in use, the data that backs it up will get deleted, which is fine for the vast majority of these things, because these are all long running. So, your Postgres isn't going to unbind from that. So you've got no issues there. But there are other bits of the system whereby the out-of-the-box configuration, it doesn't quite work as it ought to. So if I have a look at this, I just wrote a small manifest. It's going to create a namespace, so we can do some testing in the namespace, and it's creating 2 persistent volume claims, a 10 meg one and a 5 meg one. And then it's just going to create me a BusyBox pod that mounts both of the datas so that I can do something with it. So if we apply this, this is where it might all go horribly wrong because it's a demo. Why is it doing this? Right, I'm just going to quickly see what's up with this. Oh, right. I was being smart and I wanted to try and show 2 different problems at the same time. And so I edited this just before we started the stream. And so I've obviously not done it right. So quick look, 5 meg data, 10 meg data, 10 meg data, 5 meg. Right. Okay. So as I was saying, it's a demo and it's probably going to go really well. Okay, so we've got a pod now. It's running BusyBox, which is just an interactive sort of utility shell. So if we exec into it, PV demo. and show that we've got the PVs mounted. So as you can see, it's an NFS one because we've deployed the NFS subdir provisioner on this, which you get with the default Viya install. So we've got one on /data, which is the 5 meg PV, and then we've got the 10 meg PV on data 2. So if we go to /data, so this is the 5 meg one we've allocated, and we should be able to store 5 meg in it and no more. So if we just create a file, block size 1 meg, count, let's do 10. Right, so obviously in our 5 meg PV, we've just written 10 meg of data. So it turns out the NFS provisioner doesn't enforce the size restrictions. Most of the other ones do. So if this was, say, an Azure disk that got provisioned, we'd have got a stop. But there's nothing to stop any errant stuff completely killing your NFS server. So it's something you need to bear in mind. There isn't a fix for this at the moment. The second issue is that the PVs, if we list them, let's filter on that. So you can see we've got a 10 meg, a 5 meg. They're both bound, and they've got a reclaim policy of delete. So in a minute, we're going to fake a terrible accident, which is realistic and could happen. And we're going to see what happens to the PVs. The reason I'm talking about this is because if we look at the other PVs and filter for ones called backup, there's two. So that's the common backup data for CAS, and that's the one that backs up the rest of everything. And these are both out of the box got a delete reclaim policy. So if we just edit my PVs so we don't break the system. So edit PV, let's edit the 5 meg one. So what we're going to do is we're going to explicitly set the reclaim policy, change it from delete to retain, and then apply that. There are other ways of doing this. You can add patch files as part of your installation steps. So when you've been doing the Viya install and you get to the customize and changing things from SAS bases into site config and so on, you can apply files in there that will do this for you. So it's not a case of you have to try and play this video back and see what I was doing. So let's check the policies now. Cool. So we've got one with retain, one with delete. So if something happened, like you had a shared test dev staging environment, possibly production, even in the same cluster, and then somebody's doing some tidying up one day and they delete a namespace like this. If we go and have a look here. So this is the NFS server. This is where all of our PVs are actually backed by real directories and data. So as that namespace is being deleted, it'll take about 45 seconds or so. If we look at this again, we've still got both. Oops, wrong one. Right, so we've lost the 10 meg PV, which is the one that we'd not changed the reclaim policy on. So if this happened to your Viya namespace, that's a bad day anyway, but it's a super bad day because all your backups have just been deleted as well. So what you'd need to do is obviously go and change the reclaim policy on these and set them to retain. And then even if the PV gets trashed or your namespace gets trashed or almost anything else that would go wrong in the cluster that killed the cluster, then your data still survives and you get to do recovery. Right, so that's PVs, let's patch those. Another one on disks, on storage. It's worth going over these because storage is, as I said, it's quite an odd thing to get your head around when you first start doing Kubernetes. So everything's got storage class. When we created demo PVs, you see we specified a storage class name of SAS. So that's something that comes as part of the SAS install that you configure. And then these are the storage classes. And this explains, what service you go to, or what service Kubernetes goes to go and get your file generated. These here, the default one in particular, they're all backed by Azure on an AKS cluster. And so whilst you might think that you've done the NFS setup, you've got your NFS server and you've stuck loads of quite expensive disk on that, when you look at what your PVs are actually doing, you've still got some that have come through as default. And unfortunately, these are some of the largest ones. So if you're doing, say, a cost reservation deployment to try and get more reasonable rates, particularly if you're then doing a pre-billing for a client or something, you're not aware that this is now deploying on demand PV requests into Azure. So depending on the configuration you do, you could be backing these with Ultra or Geo resilient premium SSD or something. So this one just happens to be on a standard SSD, but that's 128 gig allocation that we weren't expecting to make. And as you can see, we have quite a few of them. If the cluster had been around longer and had done more and also was fully working, there'd probably be another 10 or so of those. So that could quite suddenly add up to unexpected cost. So enough pointing out the things that aren't quite super. Here's some stuff that actually is really cool. So there's a SAS readiness pod, which is really useful. So as I said, this cluster was spun up yesterday and it's not in the healthiest state. I'm trying to do some work at the moment to deploy clusters in smaller resource requirements than SAS recommend, but still have a working cluster, with the proviso that performance won't be as it would be, but it will still function. So it's been up 19 hours. If I get the deployments, you'll see not all of them are running. Most of them are, but we've got a couple here. So CAS isn't running because CAS wanted to take all the resources in the world and wasn't happy when I said no. But most of them are going. So we've got the SAS readiness pod. And if you pull the logs from that, you get quite a lot of data. It's not entirely super useful as it is by itself. You could pipe it into Vi or something. Oops, wrong one. But still, it's a bit hard to parse it. It's JSON, and I think, it's not natural to be able to just read JSON for long periods of times without getting eye strain. So if we pipe it through JQ, it's much better. This one is a much longer log file than normal because this one started off and nothing was working. And I've left it running for 19 hours, so it has accumulated quite a lot of different updates. But yeah, you see, by piping the output of the pod through JQ with the default filter on it, it's now, it's actually providing useful information, whereas it wasn't really before. And that works for most of the SAS pods. A nice thing as a Kubernetes, but not a SAS person, the approach SAS have got to dumping logs on all the pods is pretty cool. There's lots there, and you can generally figure out what's going wrong just by looking at the logs for it. So I think this is one that was causing a problem earlier. Yeah. So there's a lot in here that's quite useful. You can put this into the monitoring solution with the OpenSearch, but OpenSearch then seems to want more resource than your Postgres does. So depending on your ability to be willing to pay large amounts for massive nodes, you might find that you get okay with just looking at the pod logs. And the next one, SAS orchestration. This is really cool and super useful. So when you read the SAS deployment docs, very often it will say use customize 3.7.0 or use kubectl this version. And it turns out they do say that for a good reason. It's not ideal, but there is quite a lot of rate of change with the Kubernetes tools. And it turns out if you run some of the deployment stuff with not the right version, it doesn't work. It processes and you get some output, but then when you try and apply the output, it's not a usable setup. So as well as saying you have to use these mandated versions, they do give you an easy way of doing it. So there's a SAS orchestration pod, which you can pull from SAS's container registry. And so I'm just running it here interactively. If you don't do it with this, so I've specified an entry point by putting that parameter in. You need to do that before the pod, before the image name. Anything after the image name is a parameter to whatever's running inside the image. And so I always forget this about every 50% of the time, and then it starts complaining because I'm passing parameters to the image rather than passing parameters to Docker. So yeah, we've got I've mounted some, well, essentially a deploy directory that I'd made. So we've got customize of the right version. We've got kubectl, and I also cross-mounted using, I think this version's got it in. Yeah, so I cross-mounted my home/.cube/config file in, so I can interact with the cluster from in here as well. You've also got the orchestration tools, which are worth exploring, and the life cycle stuff, but I don't think that's something I should go into now because we could spend a day on that. But yeah, so SAS orchestration pod, you've probably already got it if you've run any of the deployment stuff locally. But if not, you can just pull it. Right. Oh yeah, and another tooltip or planning one. So the deploy folder, as it turns out, is life. If you lose your deploy folder, then everything's bad. And it's pretty hard to recover from that. So let me find mine. Sorry. I was up quite late getting the cluster working, and so I didn't go to sleep overnight, probably as long as I ought to have done, but it's okay. Right, yeah, so this is the output of the IAC preparation. So this deployed the Azure infrastructure, didn't deploy any software in there, so it's a bare cluster at this point. And obviously you need this, and super critical is the Terraform state, because this has got all of our secrets in. It's got your initial kube config, it's got the corresponding parts for the SSH keys, and everything else that you need if you ever need to change anything without completely blowing away the entire infrastructure. So you need to protect this. So obviously you probably stick it in a Git repo like this one is. But then because it's got credentials in, you need to make it a private Git repo, otherwise bad things. But then when you do a check-in, you find that unless you've got the enterprise GitHub, you can't do the commit. And so it's going to moan. Eventually it'll moan and tell you it's moaning about LFS. And so it turns out in the Terraform folder, you've got the providers. So everything that's listed in your providers file. So this is like Azure RM, well, the various Azure ones, because there's many, and anything else that you're using. And they're all going to be stuck in here. And that one, the Azure RM, is massive. So that's 168. Even the old version is about 130, and that's bigger than the largest file you can commit to a GitHub repository without paying and enabling for the Git large file support. So it's super important. When you do your deploy and it's worked and it's like, okay, I'm going to save this config. This is a good one. This is now our live config. We're going to need it when doing patching and stuff later on. You stick this in Git and you do a git init, but you need, can I spell? Yes, I can spell. Yep, you need to block the Terraform folder from being added to Git. Otherwise, you end up spending 2 hours doing a Git rebase as you go and try and pick through to find the commit that accidentally checked in the 168 meg file. That means that you can't back up this incredibly important data set. So, yep, write a Git ignore and make sure you're not backing up your providers. You don't need them. When you come back to this later on, if the provider is still there, that's fine. If they're not there, then Terraform init will go off and bring them back, and it'll bring back the right versions because your provider's configuration specifies all things you need to know. So there's no downside to this. It just causes you a problem if you don't. And then the last one is Terraform itself. Terraform is smashing. I've done this sort of thing without Terraform, and it's so much better with Terraform. The only problem is this IAC repo isn't quite where it needs to be yet. When you do the configuration, you specify, or you can specify, a resource group to deploy into. And so you think that's cool. I've got this resource group. Generally, your subscription owner or administrator is going to create that for you and then delegate you a contributor role to that resource group. So you set that in and then you start doing the deploy, and it chugs and chugs, and then it gets most of the way through when you do the network configuration for AKS, and then it fails. And so the problem is further down in one of the AKS scripts, it wants to build a new resource group to store the network objects, which is, well, it's this one actually. And the problem with that is if you run the installer in the recommended way, which is to use the TF vars for client ID and client secret, you've created an Azure AD service principal, and you will have given it rights to, you'll have given it rights to the resource group you're going to deploy to. So we look at this one. I'm not sure if you'll be able to see this now because I've had to get elevated rights on this. I think it's still there. Yeah, so you can see that was the one that I followed. In fact, it follows the name. It's standard in the Azure doc too. Sorry, in the Azure IAC doc. But you're using that service principal. You then run all of the Terraform apply and so on. It executes as that service principal, and then it gets to the 3/4 of the way through, and it tries to do the AKS network config again as that service principal, and it's operating now outside of that resource group, and so it can't do anything, which is a bit annoying because it does take quite a while to get there. So if you're in a rush as well, it's a long iteration time. So I've done some work. I now know why it's doing that. I made it so it didn't do that. It didn't like it. So I need to, so my to-do list to go back and find out exactly why that fails. But yeah, that's something to bear in mind. If you're going to do this the way the documentation on the SAS repo says, you do need to have a service principal allocated at the subscription level, which is a bit, well, I think that's quite excessive. But you know, that's the only way to do it. You can't use Azure CLI authentication because in your CLI, so I'm authenticated there. When you run the Docker container that does the TF plan, TF apply, that doesn't pick this up and doesn't bring it through. So the AZ CLI inside Docker has no authentication. It's the client ID and the client secret that's being passed through. I did try and change the code or the Terraform HCL so that it would take a pass through for me, but there's quite a lot of dependencies further inside where the people that wrote the Terraform have made assumptions that it will be done as a service principal. So that's not an option at the moment, but it is annoying when it happens. Right, okay, I think that's my planned bit of this done. So Does anyone want to ask any questions or anything like that? I don't know if I can see the chat.
Yeah, there's nothing in the chat, but if anyone wants to ask anything, just unmute yourself and fire away. If you haven't got anything now and you want to follow up with any questions afterwards, then obviously we'll be happy for you to do that and reach out to us.
Certainly.
So yeah, it doesn't look like we've got anything right now, but so yeah, thanks, Tim. Yeah, and I hope everybody found that interesting. You're 19 participants today, so it's a really good turnout. Yeah, like I said, we're happy to pick up questions afterwards if you want to follow up with us directly. We'll be putting a copy of this recording on our YouTube channel, so look out for that and share that around with others. Our next Saguki meetup in December is going to be face-to-face in London. We've just had the agenda sort of confirmed on that, so SAS are going to be presenting on the SAS Viya 4 roadmap, and we're also going to be presenting on our own SAS Viya 4 migration accelerator tool. So sharing with you a bit about that product and what it does and how it helps with your migration or upgrade to SAS Viya 4. We'll also be having food and drink provided, so it'd be great to see some of you face to face. If you can't make it face to face, we're also going to try and broadcast it as well, so it'll still be available online. So again, thanks for your time. Enjoy the rest of your day, and yeah, like I said, if you've got any questions, just reach out. Thank you.
Yeah, that would be really cool to talk about. I will drop my email.
Great, yeah, we just had a question come in. So yeah, Tim can pick that one up with you, Kate's, and contact you directly. Thank you, everyone.